You know, in Python, there's this data structure that's often sitting in the background, but it's incredibly powerful. It's the tuple. You've probably seen it, maybe even used it without thinking too much about it. Well, today, we're going to pull back the curtain and really dig into what makes it so essential.
So let's just get right to the heart of it with the big question. In a world where everything is about dynamic, changing data, why on earth would you ever want a data collection that you can't change? I know, it sounds kind of like a bug, right? A limitation. But what you're about to see is that this limitation is actually its greatest strength.
Okay, so first things first, what exactly is a tuple? Honestly, the easiest way to think about it is as a read-only list. It's a container for your data that, once you create it, is pretty much set in stone. And that's really the core of it. Just like a list, it's an ordered collection of items. That means the order you put things in is the order they stay in. You can have duplicates, you can mix and match data types, no problem. But, and this is the big one, it's immutable. Once that tuple is made, you can't change what's inside, period.
So when you boil it all down, this is the fundamental difference. Lists with their square brackets are mutable. They're flexible. You can add things, remove things, change things. But tuples with their parentheses are immutable. They're constant. This one difference is what drives the decision of when to use which.
All right, enough theory. How do we actually make these things and get data out of them? Let's get practical. It's actually way simpler than you might think.
You've basically got three main ways to do it. The most common is just using parentheses. But here's a cool little Python trick. The parentheses are actually optional most of the time. Python is smart enough to see a bunch of values separated by commas and just know, yep, that's a tuple. And of course, you can always convert something else, like a list, directly into a tuple using the tuple function.
Ah, but here it is, the classic rite of passage for every Python developer. You try to make a tuple with just one item, you wrap it in parentheses like you're supposed to, and you don't get a tuple. Python just sees the number 10 inside some parentheses, which it interprets for math, and gives you back an integer. It's a gotcha that gets everyone at least once.
And the fix is so simple, it almost feels weird. You just add a comma. That single trailing comma is the secret signal to Python that says, hey, I'm not just a number in parentheses, I'm a collection that happens to have only one item. It's a tiny piece of syntax, but it makes all the difference.
Now, once your tuple is created, getting stuff out of it is a breeze. It works exactly like a list. You use square brackets and the item's index number, 0 for the first, -1 for the last. Or you can slice it up to grab a whole range of items. Nice and familiar territory here.
But what happens if we try to break that one big rule? Well, here's the proof in the pudding. We make a tuple, and then we try to change the second element to 70. And boom, Python stops us dead in our tracks with a type error. The message couldn't be clearer. Tuple object does not support item assignment. That right there is immutability in action.
So if we can't change them, what can we do with them? Well, it turns out a whole lot. Let's open up the essential toolkit for working with tuples.
You can use some familiar math operators, which is pretty neat. The plus sign will concatenate two tuples together, and the asterisk will repeat a tuple's contents. But look closely. In both cases, what you get back is a brand new tuple. The original tuples are left completely untouched, which perfectly preserves that whole immutability thing.
And you've got a whole suite of handy built-in functions. You can get its length with len, count how many times an item appears with count, find where an item is with index, and find the min and max values. But check out the sorted function. This one's important. Since a tuple can't be changed, sorted doesn't sort the tuple in place. Instead, it gives you back a brand new sorted list made from the tuple's elements. Okay, so this brings us to the main event, the big question. We know what they are, we know how they work, but when should you actually choose a tuple over a list? This is where the rubber meets the road.
Let's break it down. We've got syntax, square brackets versus parentheses. We've got mutability, changeable versus not. That leads directly to the use case. If your collection of data is going to change over time, use a list. If the data is fixed, like coordinates, color values, or configuration settings, use a tuple. But that last row, that's the real game changer. A tuple is hashable. Think of it like having a permanent, unique fingerprint because its value can never change. Python dictionaries require their keys to have this fingerprint. A list can't be a dictionary key because its contents might change, but a tuple, it works perfectly. That is a huge advantage.
All right, before we wrap up, let me show you a couple of pro tips. These are some really elegant and powerful techniques that make working with tuples just awesome.
This has got to be one of my favorite features in all of Python, packing and unpacking. When you write t equals a, b, c, you're packing those variables into a single tuple. And the reverse, unpacking, is where the magic happens. You can assign all the items from a tuple to individual variables in one clean, beautiful line of code. It's fantastic for things like swapping variable values or having a function return multiple results at once.
Now, if you're a fan of list comprehensions, that slick, one-line way of building a list, you're probably wondering, can't we just do that with tuples? Just swap the square brackets for parentheses and call it a day?
And here is the big twist. Nope, you can't. There's actually no such thing as a tuple comprehension in Python. When you use that syntax, the one that looks like a comprehension but with parentheses, you don't get a tuple. You create something totally different and very powerful, called a generator. It's used for super memory-efficient calculations, but it is definitely not a tuple. Another great gotcha to keep in your back pocket.
So as we bring this all together, what's the big takeaway here? A tuple isn't just a list that you can't change. It's more than that. It's a statement. It is Python's way of letting you, the programmer, guarantee that a collection of data will not and cannot be accidentally changed. It's all about ensuring data integrity. This quote really just says it all, doesn't it? The decision is actually pretty straightforward. If your data is fixed and it's never supposed to change, a tuple isn't just an option. It's the right choice. It's the safer, clearer, and more professional choice. So remember, immutability is not a weakness. It is a powerful feature for writing safer, more predictable, and more readable code. It communicates your intent loud and clear. So the real question to leave you with is, now that you can protect your data with tuples, what will you build with that reliability? Thanks for joining.